It is late, the fire has burned low and somebody is chewing. They have been chewing for most of the evening because the food demands it. Tough roots, dried meat, seeds that fight back against every bite. Their jaw aches, it has ached every night of their life. And in that whole life, they have never once had toothache. No cavity, no abscess, no crooked crowding at the front. Now hold that mouth and slide it forward to yours. Almost everyone watching this has had a filling, a brace, or a wisdom tooth out. We assume that is simply what human teeth are like. It is not, it is what human teeth became. But here is the part that ruins the easy version of this story. Ancient people did get cavities, some of them an awful lot of them. Start with what is actually in the ground. Teeth are the hardest thing in the human body. Enamel outlasts bone, which outlasts everything else. So when almost nothing else survives from a person, their teeth often do. Which makes prehistoric mouths one of the best records we have. And when you line up enough of them, a pattern appears. Hunter-gatherer jaws, over and over, come out of the ground clean. Full sets, even spacing. Teeth worn flat but not rotted. Wisdom teeth sitting in the row like they belong there because they do. Then farming arrives, and the same region's mouths change. Cavities appear, abscesses appear, teeth crowd and twist. The change is not subtle, and it is not slow. It shows up wherever people take up agriculture, on different continents. Different crops, different centuries, same mouths. Which is the sort of pattern that makes archaeologists sit up. One thing showing up independently in many places usually has one cause. So the obvious question is what farming actually did. And the answer splits into two completely separate problems. One is about rot, the other is about shape. They have different causes, and they are usually confused with each other. So we should take them one at a time. There is one caveat worth putting on the table straight away. Skeletons do not arrive as a fair sample of anyone. Who got buried where and whether their grave survived. All of that filters what ends up on a laboratory bench. So a single cemetery can mislead you badly. The reason this pattern holds is that it is not a single cemetery. It is the same shift, found separately by different teams, on populations that never met and never shared a crop. That is what turns an observation into a finding. A cavity is not really damage, it is digestion. Bacteria living on your teeth eat sugars and starches and give off acid. That acid dissolves enamel from the outside in. So a cavity is a hole made by something else's meal. Which means the question is not how hard people brushed. It is what was living in their mouths and what those things were fed. And we can actually answer that because plaque fossilizes. Hardened dental plaque traps bacteria and preserves their DNA for thousands of years. Researchers sequenced it from more than 30 early European skeletons. The oral community shifts at exactly the hunting to farming transition. Before farming, a broad mixed population of species. After farming, a narrower one, tilted toward the acid producers. The bacteria that thrive on starch got a permanent food supply. Grain is starch. Stored grain is starch available all year. So a mouth that used to get varied, tough, low-starch food now gets soft, sticky, carbohydrate-rich food every single day. And here is the detail that surprised even the researchers. After that shift, the oral community then stayed remarkably stable. Neolithic, Bronze Age, Roman, Medieval. Broadly the same mouth. For thousands of years, nothing much moved. Then it shifted a second time, at the Industrial Revolution. Processed flour and cheap sugar arrived at scale. And after that, the cavity-causing species became genuinely dominant. So there were two shifts, not one. Neolithic starch, then industrial sugar. Modern mouths are also markedly less diverse than ancient ones. And low diversity is exactly what lets one species take over. A crowded, competitive community keeps any single member in check. Now the complication, and it matters more than the neat version. Hunter-gatherers did not universally have good teeth. At a site in Morocco called Tafouralt, researchers found something awkward. These were Pleistocene hunter-gatherers, no farming anywhere near them. And roughly half the teeth examined had cavities. Half in a population that never planted anything. So what were they eating? Acorns, enormous quantities of starchy acorns gathered and stored. Sweet acorns that can be kept and eaten through the year. Which is, nutritionally, very close to what farming would later provide. Heavy starch available constantly, sticky when processed. The bacteria do not care whether you planted the plant. They care whether starch keeps arriving. And at Tafouralt it did. thousands of years before agriculture. This single site does something important to the story. It removes farming as the cause and puts diet in its place. Being a hunter-gatherer never protected anyone's teeth. Eating tough, varied, low-starch food protected their teeth. Most hunter-gatherers happen to eat that way. These ones did not, and their mouths show it. Which is a useful reminder about how this kind of evidence works. A pattern with an exception is not a broken pattern. The exception is usually where you find the actual mechanism. So the rot half of the story is really about starch and stickiness, not about farming and not about brushing. That leaves the second problem, which has a completely different cause. It is worth being precise about what a cavity actually is here. Archaeologists are not guessing from a dark patch on a photograph. A carious lesion is a physical hole in the mineral surface, examined directly, often under magnification and scored to a standard. Which is why a figure like half the teeth means something. It is a count of real holes in real enamel, tooth by tooth. Crooked teeth are a different problem entirely. Nothing is rotting, nothing is being eaten by bacteria. The teeth are fine, there is simply not enough room for them. And that is a question about the size and shape of the jaw. So somebody went and measured, properly and at scale, 322 craniums, 295 mandibles, drawn from 11 different subsistence groups around the world. 6 of them farming populations, 5 of them hunter-gatherers. And crucially, the analysis controlled for genetics, geography, and climate. Because all 3 of those obviously shape a skull too. Strip those out and one difference survives. Farming populations have shorter, broader jaws. Hunter-gatherer populations have longer, narrower ones. Consistently across the world, regardless of ancestry. Now put that next to a second fact. The teeth themselves barely changed at all. Same number, roughly the same size, same order of arrival. So you have the same teeth in a shorter jaw. There is only one way that can resolve. The teeth crowd, they rotate, they come in at angles. And the last ones to arrive find no space left at all. Which is exactly what a wisdom tooth is. Not a useless leftover, a tooth that used to fit. The mechanism proposed is mechanical, not genetic. A jar is bone and bone grows in response to load. Chew hard for years while you are growing and the jaw develops robust. Farming brought grinding, soaking, and above all cooking. Softer food, processed food, food that asks far less of a jaw. Less loading during development, less growth. The result is a jaw that never quite reached the size its teeth expect. Now here is the thing the Golden Age version leaves out. Ancient teeth were not comfortable. They were worn down savagely. Look at a Neolithic molar, and the top is often flat. Not chipped, not decayed, filed down like a worn stone step. And the cause was sitting in the food itself. Grain has to be ground before you can do much with it. For thousands of years that meant a quern, which is 2 stones. You put grain between them and work the top stone back and forth, which grinds the grain beautifully and grinds the stones as well. So fine stone dust goes into the flour along with everything else. Every loaf carries a quiet dose of powdered rock. And a tooth, hard as it is, cannot win that argument over decades. The enamel goes first, worn flatter with every passing year. Underneath is dentine, which is softer, so the wear speeds up. And under that is the pulp, where the nerve actually lives. Wear far enough down and you expose it, which is an open channel from the mouth straight into the nerve. That is agony, and it is also an open invitation to infection. Abscesses in ancient jaws are common, and often this is the route. Not a cavity eating inward, but where grinding steadily downward. There is a rather nice detail buried in all this. When grinding technology improved, the wear pattern changed with it. Researchers can read the scratches on a tooth under magnification. Coarser grinding leaves broad lines, pits, and punctures. Finer rotary querns leave a gentler, more even signature. So the marks on a tooth record the machine that made the flour, which is a remarkable amount of information from one worn molar. And it tells you these people paid for their bread in enamel, which raises a question nobody expects to have an answer. If ancient mouths hurt this much, did anyone try to do anything? In a Neolithic graveyard in Pakistan, at a site called Mayagar, researchers examined the teeth of people buried between 7.5 and 9,000 years ago. And in 9 of those adults, they found something genuinely startling. 11 molar crowns with neat holes drilled into them. Not cracks, not wear, precisely shaped circular holes, drilled through the enamel and down into the dentine beneath. Under magnification, the walls of those holes carry tool marks. Concentric rings, consistent with a drill spun by a bow. And the site itself is full of flint drill heads, the same kind used there for making beads. So somebody took a bead-making tool and used it on a living jaw. The teeth show signs of continued wear afterwards, which means these people were alive when it happened, and went on eating for years after. Now why do it at all? Every one of the 11 is a first or second permanent molar. Those sit right at the back where nobody can see them. So this was not decoration, and it was not display. 4 of them show decay associated with the hole, which points toward treatment, drilling out rot or relieving pressure. The honest answer is that the motive is not certain. But whatever they were attempting it deliberately, with a specialized tool on the teeth actually causing trouble. 9,000 years ago, with no anesthetic of any kind. Which is either the most reassuring fact here, or the most alarming. Possibly both at once. Come back to the tooth that causes the most modern trouble. The third molar, the wisdom tooth. It has a reputation as a useless leftover, a spare part that evolution forgot to delete. That is not really what it is. For most of human history, it was simply the last tooth to arrive. It comes in the late teens or the early 20s, long after all the others have settled into place. And there is a good reason for a tooth that shows up that late. Chewing tough food wears teeth down. We have just seen how much and how fast with grit in the mix. A mouth grinding hard food for decades loses working surface. So a late arrival is a fresh grinding surface, delivered when it is needed. A replacement, timed for a mouth that is already worn. In a long, robust jaw, there is room at the back for it. It erupts, it lines up, and it does its job. In a shorter jaw, there is no space left by the time it arrives. So it pushes hard against the tooth in front, or turns sideways, or never fully breaks through the gum. That is impaction, and it is a spacing problem, not a design fault. The tooth is fine, the room is gone, which reframes the whole thing. Wisdom teeth did not stop being useful. The jaw they were built for stopped being built, and that is a change measured in a few thousand years, which is nothing at all in evolutionary terms. Far too fast for the teeth themselves to have adjusted. So we are carrying a full ancient set of teeth, in a mouth that has quietly downsized around them. It is worth stopping on how much a single tooth can tell you, because the hardened plaque we mentioned is not only a bacterial archive. It traps whatever was in the mouth while it was forming. Starch grains from plants, fibers, pollen, occasionally soot. All of it sealed in a mineral crust and left for thousands of years. So a single crusted molar can tell you what somebody ate. Not in general, but in the last stretch of their actual life. The bacteria tell you what community lived in that mouth. The trapped particles tell you what was being fed to it. The wear surfaces tell you how tough the food was. And the scratch pattern tells you how it was processed. The shape of the jaw tells you what the bone grew up doing. And a cavity tells you something starchy stayed on the teeth. That is 6 independent lines of evidence. From one object, from one person, from one lifetime. Which is why teeth are so disproportionately useful in archaeology. Most of the past has simply rotted away. We spent a whole video on clothing, which survives almost nowhere. Teeth are the opposite problem, they persist almost too well. They are the most durable, most information-dense thing a person leaves behind. And there is something quietly striking about that. The part of you most likely to outlast everything else is the part that spent your whole life being ground down. It records the damage, and the damage is the data. A perfect, unused tooth would tell us almost nothing at all. It is the wear, the crust, and the holes that carry the information, which is a strange sort of comfort if you have a filling. You are already leaving a very detailed record. So if the old mouth worked better in some ways, why not return to it? The honest answer is that nobody would take the trade. Look at what the softer diet actually bought. Cooking and grinding make calories far easier to extract. You get more energy from the same food with far less chewing. That is hours of every single day handed back to you. A hunter-gatherer jaw is a jaw that works for its living. Chewing tough food is a real-time cost every day for life. Softer food also means much less of the wear we just looked at. Fewer teeth ground all the way down into the nerve. And crucially, processed food can be fed to people who cannot chew. The very young, the very old, the sick. A society that can feed those people keeps more of them alive. So the change was never really about teeth at all. It was about calories and time and who gets to survive. The mouth was collateral in both directions at once. We lost the tough diet that kept the bacteria in check. We lost the mechanical load that built a bigger jaw. And we gained a food supply that could support far more people. There is no version of this where anybody notices and chooses. The costs land on individuals slowly, across a whole lifetime. The benefits land on populations, and they land immediately. That asymmetry is why so many of these changes stick. And it is worth saying plainly what this is not. This is not an argument that you should eat like a hunter-gatherer. The evidence here is about jaws growing across childhood, and bacterial communities shifting over thousands of years. It is archaeology. It is not a plan for your Tuesday. So put the two halves back together. Cavities come from what the bacteria in your mouth are fed. Starch and sugar arriving constantly in soft, sticky form. That started with Neolithic grain and got much worse with industrial sugar. And it was never really about farming because Taforalt got there first with acorns. Crooked teeth come from something else completely. A jaw that grew under less mechanical load than the teeth were built for. Softer, more processed food during the years the bone was still forming. Two different problems from two different aspects of the same change. Which is why the popular version, ancient people had perfect teeth, is wrong. They had teeth suited to what they ate. So did the acorn eaters, and it did not go well for them. And there is one more thing worth being honest about. Ancient teeth were not painless, they were worn down hard. Decades of grit from stone-ground food filed them flat. Some were worn into the nerve, which is its own kind of agony. So this is not a story about a lost golden age of mouths. It is a story about trade-offs. Softer food gave us less wear and more time and more calories. It also gave the bacteria a permanent feast and gave the jaw less work. Nobody chose that trade. It arrived attached to something else entirely, which is how most of these changes actually happen. You do not adopt a diet in order to change your face. You adopt it because it feeds more people and the face follows. So the next time you run your tongue along a filling, that is not a personal failing and it is not bad luck. It is a 10,000-year-old bargain still being paid off in a mouth that was built for a completely different meal.